Hello. Today's topic is on the introduction of a theory which is called minimum sum theory. And simply, before I introduce this theory here, I just would like to show it through a numerical example or just through an example. Imagine that you have got a set of n positive numbers, x1, x2, x3, and to xn. Certainly here this is the aim of this topic. Maximum sum, which is denoted by S max of these numbers, is a very simple one, which is definitely the sum of all these positive numbers. So if you add all of them, this gives the summation, which is the maximum. But definitely now, the question is how to find the positive minimum sum for these numbers. Certainly here, some of those figures, if you look at it mathematically, this equation here, which is the sum, but this sum here is plus minuses. So what we mean by plus minuses, so it means every single x, x1, x2, x3, may take positive or negative, in which this produces a minimum value. Then obviously, if positive is not important in this theory here, the minimum sum is simply negative of the maximum sum. But this is not what we are interested in because this is fairly easy. Then this presentation now introduces and devises a method, an algorithm to work out this positive minimum sum of a set of positive numbers. Definitely here, this is tricky and needs a method to do the job. It's not something in which simply we can just add or subtract few numbers. This is the aim of this presentation. I start with producing an example. Let us just give a very simple example. We have got a data, and this data are 3 elements, 15, 3, and 9. Then the maximum fairly easy, which adds all of those. But now to work out the minimum, let us write down all the arrangements or possible arrangements of the algebraic sums. Certainly here, because we have got 2 positive and negative signs here and 3 numbers, then there are 2 to power n possible sum arrangement, which is in this case 8, and this is listed here. Then like 15 plus 9 plus 3, which is 27. This was the maximum one, and then so on, so on. But definitely here, we are not interested in negative ones, so we cross them out. So it means 4 possible outcomes are here, or arrangements. And then this is obvious that 15 minus 9 minus 3 is equal to 3. This gives the minimum sum. So it means the sign of 15 is positive, the sign of 9 is negative, the sign of 3 is negative. But definitely here, in this case, which is the minimum, we cannot apply this in a practical way. Because imagine that if you have got 10 positive numbers, and just for simplicity, and sometimes maybe in reality you have got even 100 positive numbers. Hundreds, thousands of positive numbers. So it means now we need to have 2 to power 10 lines of calculation. And if each calculation for each line takes around 25 seconds to note it down, doing the summation or subtraction, and then noting down the result, then the total time required may be around 7 hours or more to do just 10 digits here or 10 numbers. Because this is not a practical one, and then what we do, we introduce an algorithm, a methodology here in which to do the job, which is fairly very easy, and then I'm quite sure you can understand it easily. Now what is this first step? Put the data in descending order. So if the data in which you have is not in order, put the data in descending order, so from the largest one to the smallest one. Then later on, work out the absolute value of the difference between the first 2 numbers, x1 minus x2, and the absolute value. This is the sign of the absolute value. So it means whichever is greater, it doesn't matter because we just need the positive result. Then later on, this is now a new number, and then you calculate the difference between this number and x3 and also the positive figure, which is the absolute value, definitely. And then you repeat this, you continue this process here until the end of the data, and automatically here this will be the S minimum, and this is the expression mathematically here. So the S minimum is so many absolute values like n times, and then x1 minus x2, then minus x3, then minus x4, and so on, then minus xn. So to demonstrate that, let us apply this to a numerical example. Like this is a numerical example, 25, 19, 8, 5, and 2. And for simplicity here, I assume that the data is already in order, which start from maximum value, 25, and ending with its minimum value, which is 2. Now, solution. So this is the process or the algorithm in which I devised it. 25 minus 19, which is 6. And then later on, the difference between 6 and 8, only the positive, which is the absolute value, which is 2. Then later on, 2 take away 5, which is 3, the absolute value, definitely. And then 3 take away 2, which is 1. So according to this method, then the minimum sum is equal to 1. And then simply here, if you translate it to the sigma notation, this looks like this: sum of xi plus minus xi from I1 equals 1 and to n, which is equal to positive 25 minus 19 minus 8 plus 5 and minus 2, which is certainly equal to 1. So hopefully this is clear now. Application in physics, simply here, this is a very simple case. Assume that you have got an object and there is force 1 acting on this object, there is force 2 acting on this object, force 3, force 4, force 5, and so on until n forces. Now the question is, what is that configuration of all of these forces so that there will be a minimum positive resultant? Certainly here, the method in which I developed it early on can be deployed here, and then you can do the calculation in the same way as these forces are numbers, and then you'll reach to the minimum. Programming. Then definitely one of the biggest benefit of this algorithm is for programming, because a very simple procedure in any language can be written easily. This is the idea here. This is the procedure name. Declaration of the data types of x as array, x1, x2, x3, and so on. The smin is a variable here in which also introduced or declared as a data type. Then the initialization values of the x1, x2, x3 are given, like the one in which we had 25, 2, 9, and so on. The initial value of sum or sum minimum is equal to 0. Then there is a for loop for I equals 1 to the data size. Then smin every time is redefined as the absolute value of the smin minus the xi, I1, 2, 3, and then finally, once this is done for the whole size of the data, this is the final value of S minimum, and then it can find it easily. Okay, this is the next task here, in which we have got some other interesting and extensions results for this, but definitely we will introduce them in our next presentation. One of them is on arithmetic progression. It means the sum of minimum or the minimum sum, then arithmetic progression, then the data transformation, then some more.